Okay, so for this lesson, we're going to be continuing with estimating areas, but instead of doing a Riemann sum, we're going to be using what's called the trapezoidal rule. So let's draw a graph here in the diagram section. And I'm just going to draw a parabola. So let's say I'm going to split this up into two sections here. And normally we would do a left Riemann sum or a right Riemann sum or midpoint Riemann sum. So if we were going from the left, we would go up until we get to this curve, cut over and back down, and we do the same thing here. A trapezoidal rule means that we're going to go up on both sides until you hit the curve, and then you're going to connect across. And you can see the shape that it makes is a trapezoid. Over here, we can do the same thing, and we get another trapezoid. So we just need the area formula for a trapezoid, which is 1/2 base 1 plus base 2 times the height. Now on a trapezoid, so if I just look at this first little trapezoid here, base 1 and base 2 are the parallel sides, and the height is the perpendicular distance in between. So we're going to try an example here, and we're just going to do, for number 1, n equals 4. So we're just going to do 4 trapezoids. So first thing I'm going to do is take a look at what that graph looks like. So I'm going to go to my y equals on my calculator, and I'm going to plug in negative x squared plus 16 and take a look at the graph. And I'm going to zoom 6. I'm going to draw a sketch here. So it's an upside down parabola. And right here, now these are boundaries. Here we have an integral, and the boundaries tell us what region we're looking at. So this is saying we're going from 0 to 4. So I'm going to mark this off. 0 to 4 is this section of the graph over here. Now, n equals 4 means we're going to split this up into 4 sections. So if we're going from 0 to 4, and I split this up into 4 sections, that means I'm going to go in increments of 1. So I'm going to draw the first trapezoid in. So I'm going to start by finding the area of that first trapezoid. So 1/2 base 1 plus base 2 times the height. Now the height is going to be this distance right here, which is 1. And my bases are going to be the distance up to the function. So if I want the distance at 0, I'm going to plug 0 into my function, and that gives me 16. So the height of this, or the first base, is 16. If I want the base at 1, I'm going to plug 1 into this formula, and that gives me 15. So that's going to give us the area of the first trapezoid. Now I'm going to do the area of the second trapezoid. So the second trapezoid, if I draw that in, has a base of 1 again. The height, or base 1, at 1 is 15. And then at 2, that would be the next point there. If I plug 2 into this formula over here, that gives me 12. So that's my second trapezoid. My third trapezoid. Now the nice thing about this is that they share sides with the trapezoid previous. So 12 would be the side on the left, and the side on the right would be at 3. So if I plug 3 into this formula, negative 3 squared is 9, or negative 9 plus 16 is 7. And then my last trapezoid, 7 plus my height at 4 would be 0 times 1. So now the only thing left to do is just plug all that in on your calculator. So I'm going to go to a blank screen here and just type all that in. And that gives me 42. Now, hopefully you remember that if I want the actual value, I go to my graph, and we're going to go to second trace. Number 7 is the integral, and that's an area. And you're going to tell it we want to go from 0. So lower limit, you're going to type in 0, press enter. And then upper limit, you're going to type in 4, press enter. It's going to shade that area. And the actual answer is 42.6 repeating. So I'm going to write that down. 42 2/3. So number 2, we're going to do the same thing. This one, we're going to do n equals 4, and then we're going to compare it to the actual answer. So first off, I'm going to graph it so I know what it looks like. We have the square root of x times the square root of 1 minus x. Okay, I'm going to zoom in a little bit because it's kind of hard to see. It looks like it's a half circle. Yep. So I'm going to sketch a little graph of that over here from 0 to 1. Okay, so we're going to use n equals 4. So I'm going to split this up into 4 equal sections, which means I'm going by 0.25. And I'm going to start with my first trapezoid. So the first one is going to look like that. 1/2. The height at 0, if I plug 0 in, I get 0, plus the height at 0.25. That would give me, I'm going to plug this in my calculator, the square root of 0.25 times the square root of 1 minus 0.25, so 0.75, 0.433. And the distance between is 0.25, so 1/2 base 1 plus base 2 times the height. Second trapezoid, 1/2. The base on the left is the 0.433 again, plus, now I need my base at 0.5. So we've got the square root of 0.5 times the square root of 1 minus 0.5, which is 0.5. That's 0.5. Plus, third trapezoid, 1/2. Shares the side with 0.5. Plus, now if I plug in 0.75, that's the square root of 0.75 times the square root of 1 minus 0.75, so 0.25 gives us 0.433. Then the last trapezoid, 1/2, 0.433, plus, if I plug 1 in, I get 0. So go ahead, you can pause it. You can go ahead and plug all that in and then check your answer in a minute while I plug it in on my calculator. And if you go back, I forgot to multiply these last ones by the base. So I'm going to add that in real quick. Okay, so that, when I plug that in, gives me 0.341 if I round 3 places. So let's compare that to the actual answer. So what I'm going to do next is go to my graph again, second trace, take the integral. I'm going to go from 0 to 1. It fills it in. The actual answer is 0.393. Okay, so let's go to question number 3 on the back. Here we have a chart of x and y values. It says the function is continuous in the closed interval from 2 to 8 and has values that are given in the table above. Using the subintervals 2, 5, 5, 7, and 7, 8, what is the trapezoidal approximation of the integral from 2 to 8 of f of x dx? So they tell us the three. We're going to split this up into 3 sections. The first section goes from 2 to 5. So I'm going to start with my formula for trapezoid, 1/2. Now, if I were plotting these points, my first point is at 210. And then my second point is at 5, way up here at 530. I should have drawn that a little different. So this distance would be 10, this distance would be 30, the distance in between 2 and 5 would be 3. So my two parallel sides would be 10 and 30. The distance in between would be 3. The second trapezoid goes between 5 and 7, has heights of 30 and 40. So 1/2, the bases are 30 and 40. The distance in between is 2. And then our last trapezoid goes between 7 and 8, so 1/2. The two parallel sides would be 40 and 20. The distance in between would be 1. Okay, so let's add up all those on our calculator. That gives me 160. So that would be choice C. Okay, last question, number 4. A table of values for a continuous function is shown above. If 4 equal subintervals of 0 to 2 are used, which of the following is the trapezoidal approximation? Okay, so if I split this up into 4 parts, I've got one trapezoid here, one here, one here, and one here. So there's 4 equal sections. So let's start with our first trapezoid, 1/2. The two parallel sides would be the 3 and the 3. The distance in between our x's would be 0.5. The second trapezoid, 1/2. The two parallel sides would be 3 and 5. The distance in between those two parallel sides would be 0.5. Next trapezoid, 1/2. The two parallel sides would be 5 and 8. The distance in between would be 0.5. And then the last trapezoid, two parallel sides are 8 and 13, and the distance in between is 0.5. So again, let's go to our calculator, plug all of that in. Okay, so when I get all that plugged in, I get 12. So that's equal to 12, which matches up with choice B. Okay, so that concludes part 2 of a review of Riemann sums and then the learning of the new trapezoidal rule.